talk a little bit more about those forces of tension. So if I take an object and I suspend it on two cables like this. So years ago, one of the problems, it was a student who did gymnastics, and it was, on the rings. Okay, anything that you can suspend from two cables at an angle. We obviously, just like everything else, we need to know the angles somewhere. What forces are acting on this object, if we think in terms of sum of forces? So, let's do it this way. Let's look first at sum of forces on the x-axis. Are there forces on this thing on the x-axis? Yeah? Okay. What are they? We don't know, but we know they're there. What? There's some force of tension on the x-axis. If there was no force of tension on the x-axis, this thing would be hanging straight down from the cable. So how would we break apart the forces on the x-axis here? Trig! It's trig. So if we think about, so there is a generalized overall force of tension on each of those two cables. But what's true is that that force of tension exists in two different ways. There is, for each of them, a force of tension on the y and a force of tension on the x. And trig is what will get us the force of tension on the x and on the y. Have any of you started the force of tension problems on the worksheet? Okay, that'll be today's work. Then we have force of tension x1. We have force of tension x2. Now let me ask you this. If I told you that this thing is just hanging there in space by these two cables, is there a net force on this thing on the x-axis? Remember, if it's not moving, net force equals 0. There is no net force. What does that mean about those two forces of tension? Equal and opposite. So they have to be in opposite directions. So, there are a couple ways to handle this. And this is one other place where I kind of diverge from your book's handling of it. I think they actually say, well, ftx1 minus ftx2 equals 0. I tend to prefer to keep it as a sum, that ftx1 plus ftx2 equals 0, and I assign one of those a negative. And typically I try to stick with just Cartesian coordinate negative. It's pretty imprinted on our brains at this point that Cartesian negative makes sense to us all. So, okay, so we can set that aside. We aren't going to find anything. Well, how would we, if we look at this diagram, how would we come up with f of tx? If we're given this angle theta, what would f of tx be? So f of tx would be f of t times cosine theta. And I noted that it was ft1 and cosine of theta 1. In this case, and I didn't give you a whole lot of information here, but we're kind of assuming these angles look equal. There are problems where the angles are not equal, which are much harder. It's much, much easier if the angles are equal. So here, we can just say that ft1 cosine theta 1 plus ft2 cosine theta 2 equals 0. And we can go from there. So that's not too bad. But we don't have any numbers to attach to that. So very often in the force of tension problems, because there's nothing we can really get a grip on, the x-axis is not as useful to us. There are some exceptions where we can use information on the x-axis, like to find the angles. That's one really useful thing we can do with the x-axis. But more helpful to us is the y-axis. So I'm going to shrink all the x-axis stuff, and we'll do a sum of forces on the y-axis. And many years ago, without thinking it, I said, okay, well, let's simplify this as far as we can. On the y-axis, we have forces down, and we have forces up. And they all thought it was really funny, and I don't know why. So we have F down and F up. You can use that when you're feeling particularly squirrely and doing physics. So the force down on this object is what? And I didn't draw it on here yet because I was doing some general stuff. What is that force down? Gravity. And we, again, your book doesn't really introduce this until the third section, but you need to know it before then. And I think you probably figured it out on your own on Friday. The force of gravity on any object is its mass times gravity, times negative 9.81 meters per second squared. That's your force of gravity in newtons. That's your weight, is the force of gravity on you. So the force down is force of gravity. So we have force of gravity plus what force is acting up on this object? It's a component of the force of tension, obviously. Fty. And here we actually have two force of tensions on the y-axis. So we have Fty1, Fty2, or Ft2y. Is this thing, according to what I told you, spontaneously dropping towards the ground or rising up into the air? No. What that means is that the sum of these is 0. That the mass acceleration equals 0 and the forces on them equal 0. So we have enough information then to know, and you can, if it helps you, I like my little sort of coded arrows, stick those in so that you remember force. Oh, did I do that right? No, I did not. Force of gravity up. No. There. So what we very often do at this point is move one of those across the equal sign. So we know that the negative of the force of gravity equals force of tension y1 plus force of tension y2. Do we have enough information to figure out what the force of tension is? If we have the mass of the object and we have theta, then yeah. And in this just quickie example, I didn't give you that, but force of gravity is mass gravity, so the negative of mass gravity would equal F of t. And what would be the trig expression for F of t on the y? Sine, yeah. So it'd be force of tension 1 sine theta 1, force of tension 2, sine of theta 2. Now the last part, as long as those angles are equal, and I'm kind of giving this to you in real general terms, but as long as those angles are equal, and I tend to, if they are equal, make a note for myself out here, theta 1 equals theta 2, and therefore F of T1 equals F of T2. Therefore, do you guys use therefore notation in math for like geometric proofs? 3 little dot triangle. So therefore, well, actually I guess that therefore would go 1 up, huh? Since theta 1 and 2 are equal, force of tension 1 and 2 are going to be equal. Therefore, what we can do is say that negative mass gravity equals 2 times F of T1 sine theta 1. Because they're equal. So we're just doubling that force of tension. When we solve then for F of T, we're going to be finding the force of tension in just one cable. And the most common kinds of these problems are where you're asked to find the force of tension in the cable. So. Because there are 2 cables. So. Yes. The magnitude of the forces of tension is equal. So I think what you're saying is, wouldn't they be opposite? Yeah. In the x direction, they are opposite. So f of t x1 equals the negative of f of t x2, because they're equal and opposite. But on the y-axis, those force of tensions are operating in the same direction. Good question. No. Which purple arrow? On the x-axis. One of them goes that way, and then there's another one going that way. Okay, yeah, I didn't put that in because I was just talking about it on one side. So yeah, there would be f of t y1, f of t y2, f of t x2, f of t x1. Yeah, there would be two of them. Other questions, comments, thoughts, queries? Okay, so yeah, because there's a force of tension y with each of those cables. These are hard to draw in that regard. You kind of have to just get used to the fact that, yes, there's a force of tension in the first cable on the y, force of tension on the y in the second cable. But, you know, if we really drew that the way they're behaving, we would be superimposing those two arrows, and we can't do that and still see it. So that's a problem. But does that help? Okay, we good? You ready to tackle force of tension? When we've got a problem like this is number one from the worksheet. You know, we have some object, which actually once Joe's holding the pumpkin, Joe and the pumpkin are one object. It's the Joe and pumpkin. There are forces down on him and the pumpkin. There are forces up on him and the pumpkin. Now, there may be forces to the left and right. We don't know. We're not told. What I tend to do is sort of a matter of habit, is I go ahead and do a little sum of forces x. We're not told that he's moving left or right. You know, there could be forces on him, there could be no forces, there could be wind blowing, you know, there could be butterflies fanning him from the left. I don't know. Don't care, but I just kind of do that for myself and then kind of set it aside. Whoop. Okay. Because what we're really concerned about is the sum of forces on the x-axis. Now, you've all drawn lovely pictures, and I tend to do this too because it's fun. And I have my little Joe with his little pumpkin and his little teeth and all that good stuff. And it's entertaining. Yeah, okay. It's just getting worse. Okay. But really, it doesn't matter. And we want to remember that in physics and in force problems, we deal in gross simplification. And there's Joe and the pumpkin with the forces on them. So what on the y-axis rather, what forces are acting down on him?
The weight of Joe and the weight of the pumpkin.
Okay, the weight, which is equal to F sub g, and we'll put JP, Joe Pumpkin, and that's down. What force is acting up on him and the pumpkin? Is it no? Okay, you were thinking this was a force of tension problem. If we were asking about the force of tension on the cable that he's holding in his teeth, it would be. But here, it's just what force is acting up on his feet.
Should be the force of gravity. No?
Force of gravity is acting down on him.
We're talking about ground or down.
Okay, no, we got down. Force of gravity is acting down. What force is acting up on him? Normal force. Yeah. So normal force is what's acting up on him and the pumpkin. Now, we were told that they were not spontaneously falling or rising, so these equal what? 0. Net force is 0, or sum of forces on the y is 0, which means that the negative of the force of gravity on Joe and the pumpkin is equal to the normal force. So it's a really simple one, yeah. And of course, force of gravity is equal to mass times gravity, and in this case, that is the mass of Joe plus the mass of the pumpkin times gravity. The negative of that is going to be equal to the normal force. Okay?